we have discussed how to solve equations that have two steps in them. And if I had something such as the following, 4d minus 5 is equal to 15, I tried to make sure that you guys practiced the idea of following the steps. And the steps, the reason I want you to have the steps down is so that when we get into more complicated equations such as these, you will be able to know where to begin. Now, with this one, think of the idea of what is it that I am doing to my unknown variable. It's basically saying the following, just as a quick refresher. It's saying some number, let's call him letter D. I took that number and I multiplied it by 4. That's the first thing that I did, multiplied by 4. And then I minused 5 from it. Then you minus 5. And it gave me the value of 15. So if I had a mystery number that I multiplied by 4 first, and then I subtracted 5 from him, and then I got 15, in order to undo that 15, to get back to who this person was before, this number, I'm going to work backwards. I'm going to undo in inverse order of operations. The first thing that I would have to undo would be the last thing that I would have done if I knew what D was equal to, which is the minus 5. So the first thing that you need to do is add 5 to both sides. When you do that, you rewrite what doesn't change, 4D is equal to 20. The next thing I need to do is undo that multiplication, which I use division. And to undo that, you are going to divide by 4, because if you multiplied by 4, to undo it, you divide by 4 to both sides. And when you divide by 4, you get D alone, which is what you were trying to do, and 20 divided by 4 is 5. So I know that the mystery number must have been 5, because 5 times 4 is 20 minus 5 is 15. We know that these equations, the two-step equations, oftentimes are very easy to do in your head, especially if it's like a whole number like 5 or 4, something like that. But when we have decimals and when we have integers that have lots of negatives involved, we can't just do them in our head. So it's really important that you understand the process. So you work backwards. Now, what happens, however, when you have an equation where an unknown value on both sides of the equal sign? For example, this one. If I am trying to solve for the unknown variable here, you notice that the unknown variable is x. But the problem that we may foresee is that we don't just have one x, we have 2. Just like with the regular 1- and 2-step equations that I had you guys draw the dotted line, I urge you to do the same thing with these. Step 1, separate both sides of the equal sign. Now, you are trying to find what x is equal to. The final answer that you want is going to be something like x is equal to some number. That's what you're trying to find. So hopefully by separating both sides of the equal sign, you're going to recognize that you first have to gather all of your variables on only one side. And in order to do that, you have to use the inverse operation. Looking at this equation here, can you tell me which of these two variable terms should relocate? Do we need to move this guy over here?
No.
Or do we need to move this guy, 5x, to the left?
Yeah, you move 5x.
You're going to want to move the 5x to the left because you want to get the x's together, and this x term is already alone. Here we have that constant, so we're going to leave it. For the very first couple of times, I recommend that what you do is just always try to get the x's on the left. It's going to make it easier. Just always try to get the x's on the left. So now the question is, how am I going to do the inverse? What do I do? What sign? Well, these two items are being added, but most importantly, the 5 is currently plus. So what you're going to do is subtract 5x. Because when you subtract 5x, that goes away. But whatever you do to one side of the equal sign, you must do to the other. Otherwise, it doesn't remain balanced. 7x minus 5x is 2x. That's equal to, rewrite what doesn't change, positive 4. And now it's an easy, it's just a one-step equation. All I have to do is divide by 2. And I get x is equal to 2. The most important thing you have to remember is when you're bringing things over the equal sign, when you're literally going to relocate them from here on this side to the other side or vice versa, you're going to undo what's being done. Look at the sign in front. If it's positive, you're going to subtract. If it's minus, you're going to add. Unless it's multiplying, you're going to divide, and dividing, you're going to multiply. Okay, let's look at another one. So if I was to quickly add another step, gather the variables on one side and then just solve like normal. So now, what happens if not only do I have variables on both sides, but I also have constants? Step 1, always separate. Your job is to try to find out what x is equal to. You want the answer to look like this. X equals some number. So by looking at how you want your solution, you know that you want all of the x's on the left, and you want all the numbers, the constants. Remember that vocabulary? Constant is a number without a variable. You want all variables on the left, all constants on the right. What will you do first? So a question that came up, which is really important, is basically the question was, can these two x's be a different value? No. They are occurring on the same equation. So you know that the value of these x's are the same. So whatever x is equal to, it's going to be here and here the same. This is saying I have a number, my mystery number, I multiplied by 3 and I took 2 away from it. And that whole value was the same as if I took that same number and added 4 to it. So it's like a riddle. But the only way to solve these without just guessing and checking and guessing and checking and taking forever is by gathering all the x's on the left and gathering all the numbers on the right. You could begin with the x's, you can begin with the numbers. It doesn't matter, as long as you put all the x's on the left, all the numbers on the right, the constants. So Bennett said, this is a minus 2, he should go over there, so I'm going to plus 2.
And you put the x on the other side.
Yes. So you get 3x, goes away, equals, rewrite x, plus 6. At this point, I now have an equation where there are variables on both sides, but the constants are all on the right, which is what I wanted.
Wait, isn't it 2?
So,
How is
Four.
x a constant?
and so in order to bring that x, who's on the wrong side, because he's supposed to be over there with the other x guy, I need to subtract x. Because currently, these two items are being added. However, the sign in front of the x is positive. And remember, it's the same as plus 1x. So I'm going to minus x to bring him here. 3x minus 1x is 2x. That is equal to, rewrite the 6. And now it's a simple one-step equation. If I'm multiplying by 2, I'm going to divide to solve. And I get that x is equal to 3.
Wow.
And then you check your work. 3 times 3 is 9. 9 minus 2 is 7. So this left side is really equal to 7. And then 3 because that's what x is equal to, plus 4 is also 7. 7 is equal to 7. The left side is 7, the right side is 7, because x is equal to 3. A lot of you guys like steps, so I have put together some steps just to help you. When you're solving equations with variables on both sides, first of all, you're going to simplify both sides of the equation, whether it's distributing or combining like terms. By that, I mean something like, if you had something like 2x plus 3x plus 4 is equal to something, then you would add the 2x and the 3x to simplify them. You simplify each side of the equal sign. Step 2, using the things that you've learned already, you move the variables to one side of the equation and the integers, or the constant, to the other side. Step 3, move the coefficient by either unmultiplying, which is division, or undividing, which is multiplying. Inverse operations. So let's look at this here. We're going to walk through this, which is already solved out, just to show you guys how it works. So separate both sides of the equal sign. It just makes it easier for you to see. I want all the x's on the one side, all the constants on the other. What they did here was they decided, well, first of all, you rewrite the problem. They decided that they were going to bring this 8x to the other side. So they added 8x to both sides, plus 8x plus 8x. By adding this 8x, this went away, and you just got 7 by itself, is equal to 12x, because they combined the 4x and the 8x to get you 12x, minus 17. Then they took that integer, that minus 17, the constant, and added 17 to it, both sides. Add here, you get 24 is equal to 12x. Then they got rid of that 12 by dividing. Okay? So you guys are going to try one or two. So for the first one, remember, now you guys are hopefully going to see the importance of separating both sides of the equal sign so that you can see that if you are going to cross over the equal sign, you must do the inverse. You can't just add things together if they're over the equal sign. You cannot just say, oh wait, 6x and 2x is 8x. No. In order to bring someone over to the other side, you need to do the inverse. So, if you know that you want your answer to be x equals some number, then you know you want all the x's on the left. To get this 2x over to the left, you need to minus him, because that is the inverse. And right now, the 2 is currently positive. So you get 4x. You rewrite that plus 8, because you haven't done anything with the constants yet. You rewrite the equal sign. You rewrite minus 12. Now it's just a simple two-step equation. I want to take that 8 and bring it to the other side, so I need to minus. You rewrite what doesn't change. You get 4x equals negative 20. Now we just divide by 4, and you get x equals negative 5. You can look at it and go, oh, I am going to get rid of that constant, negative 4, and bring him over. Yes. So you're going to plus 4, and you're going to line it up under the other constant, which is 5. You rewrite what doesn't change. You get 5x. The negative 4 and positive 4 cancel out, is equal to 5 plus 4 is 9. Rewrite the plus 2x. Who's on the wrong side now? 2x. 2x is currently what? Plus. How do I bring that over? Minus. So you are going to minus 2x. Minus 2x. 5x minus 2x is 3x. Rewrite the equals, rewrite the 9, and this part goes away. Now you just divide. Divide by 3, divide by 3. X is equal to 3. Some of you guys may have looked at it and said, well, instead of bringing over the 4 first, some of you may have decided, oh, I am going to bring the x's all together first. So I'm going to minus 2x minus 2x. 3x minus 4 is equal to 5. Then some of you at this point would have added 4, and you would have gotten 3x is equal to 9, and then you divide by 3, and you still get the same answer. So when I first started doing this, I would always say to myself, bring all the x's to the left, bring all the constants to the right. I just followed that process. But you have to remember that when you cross over that equal sign, you can't just say, oh, these two add up to 7. These two, negative 4 and 5 is 1. No. To bring them over, you have to undo. So it's inverse operation. Okay, let's try a different one. Sometimes you will get fractions in answers, but we're not going to work with fractions right now, so I'm going to skip this here. We're going to do this one. Step 1, separate both sides of the equal sign. So numbers on the left, variables on the left. So that means I'm going to add 4x. I'm going to add the 4x to undo him, but I'm going to bring him with his other x guy, which is 2x. Rewrite the minus 7 equals 5. Now I need to bring that 7 over by adding. Rewrite the 6x is equal to 12. Now what do I do?
Divide.
And x is equal to 2. Now, there's a question on MathSpace that I want to make sure that you guys understand, and it's going to be something like this. It's going to say 4x minus 27 equals x. With this one here, you're going to hopefully look at it and go, wait a minute, how do I bring everything over? There's only one x to the left. Bring the number 27 over first. That leaves you 4x is equal to x plus 27. And then who am I going to bring over? The x. The x. Now you're going to minus x. So you get 4x minus 1x is 3x is equal to 27. And then you divide by 3, and you get x is equal to 9.